Greetings viewers, in this video we'll continue with the Cambridge A-Level Further Mathematics Component 2 Variant 1 from the October-November Winter 2025 series. This is the just released, right, this series of past year paper. So the previous questions have been done. We will continue with this question 3. Now it's giving us with this integral in is a definite integral from 0 to 1 of 1 plus x squared to the power of n. So we want to consider this fact or otherwise to show that this statement or this equation is true. Alright, so since they're already given us this starting point, so let's try and do this from here. So if you have any other way to do this, you can try and leave the comment so you can explore also what other ways you can do this. So yeah, first we do the derivative of this expression. So definitely this is a product of two functions, so we have to use the product rule. So it will be uv prime plus vu prime, something like that. So I believe it's included in the formula sheet also. Okay, so we will take we'll differentiate x first, so it's just 1, and we'll leave the 1 plus x squared power n, and we'll add with the x, we leave it, and we differentiate this 1 plus x squared power n. So this is a nested function, so we have to use the chain rule, and first we multiply by the power, and we take away 1 from the power, right? So n minus 1. But since it's a composite function, I have to multiply whatever is the derivative of the inside function, which will give me 2x. So this will be, yeah, the chain rule. And we can try and simplify this a bit. So this front term stays the same. This second term we can rewrite as 2nx squared, and this term inside here. So on the left hand side, I'll just keep it as the same first, because what we're going to do next is we want to or we want to do something in this form where we have to include this integral, right? And if you can try and notice, whatever is in here is the same as the integrand of in. So we can try to integrate both sides, right? So 0 to 1, and we integrate the entire thing on the left hand side as well. So integrate in terms of x, 0 to 1. Okay, so on the left hand side, the integral and the differential cancel out, and we're just left with whatever is inside the expression here, and we have to do the limit 0 to 1. Now on the right hand side, I will try and separate the integrals. So this first term, right, the integral from 0 to 1 or 1 plus x squared power of n dx, you can try and notice is exactly the same as the in here. So later on we can just replace it with in. But the second part here, we need to do a bit of the manipulation. Okay, so 2n is a constant. I can just bring it off the integral. Then I have a x squared 1 plus x squared. And I will try and kind of express this in terms of power n. Then the negative one, I will break it down into a fraction. So it's easier to see why we're going to do this later for some more simplification. Okay, so let's continue with trying to deal with the left hand side. So if we substitute 1 in here, 1 multiplied by 1 power n. Sorry, 1, okay, this is 1, so 1 plus 1 squared, that's 2. So there's 2 power n when we substitute 1. And when we substitute 0, this will just multiply everything to 0. So it will just have minus 0 here. And this I'll go ahead and replace with in. And this second term. So I mean I've tried some of the integration by parts or doing the use substitution, but it doesn't work in this case. If you have any other idea how we try and solve this, you can try and leave the comment below. But from what I've tried, I cannot do the use substitution, I cannot do the integration by parts. So instead, what we're going to do is some very dirty, like we have to I want to cancel out this x squared, right? So I will try and make this similar to the denominator of the fraction. So I'll add 1 and I will minus 1. Okay, so this x squared I add 1 and minus 1, so it's still the same thing, right? I will have 1 plus x, and on the bottom also 1 plus x squared. Okay, so now I will try and separate this. Okay, so this minus 1, I'll try and take it out and expand the bracket, so to speak. So on the left hand side, 2n in, and this integral. So I will have x squared plus 1, 1 plus x squared, and 1 plus x squared. Then I would, as I said, this negative 1, I will take it out. So I have a negative 1, 1 plus x squared power n, 1 plus x squared dx. Okay, so these two integrals, they are still valid. It's just that I expand the bracket. So actually what happened here is this 2 cancel out, and this negative 1, I can take it out as a constant of the integral. So actually what we have in this first integral term here is exactly the same as this in, right? 1 plus x squared power n integrated from 0 to 1. So I will also replace this with just in. Okay, so this is in. So in plus 2n in. And don't forget, yeah, this square bracket is still encapsulating the whole both of the integrals here. So I will have to add the minus. Remember, we have a minus constant here. So minus 2n. We integrate. So 1 plus x squared power n divided by 1 plus x squared. The bottom is actually a power of negative 1. So I will combine both together. Becomes n minus 1. Okay, this is based on your exponent rules. And on the left hand side, 2n. Okay, so now this integral is the same form as this in. Okay, the only thing different is this power of n minus 1. Here, this n minus 1, which correspond to this n and this n. So all I will have to do here is I will change the subscript of the integral. So all here is in, 2n in, and I'll minus the 2n. This becomes I n minus 1. The subscript I'll just change to n minus 1, indicating that the power becomes n minus 1. Right, so on the left hand side 2n, on the right hand side this expression, I will go and try and substitute or rearrange everything in the form that the question wants us to rearrange. Okay, so in on one side, so let's have in plus 2n in here. I have 2n plus 2n in minus 1. So I think that's the exact same form as what the question wants us to express it. And we can say shown. And that's the final answer. Yep, it's exactly the same. Now we move on to part B here. Okay, part B here, we want to find the exact value of I subscript negative 2. Okay, so if we think about it first, right? If we substitute this I negative 2 straight away here, that means this in minus 1 will be in or I negative 3, which in the case where we have a power of negative 3 here, we don't know how to solve. Yeah, it will be too complicated to solve, or at your level it's hard to solve. So what we can do instead is we will take this in minus 1 as to become negative 2. So n will be negative 1. We take n to be negative 1. So in can remain as negative 1. So this whole thing, power negative 1, is just a reciprocal of 1 plus x squared, which we know how to do, I believe. So here, which we know the integral of this reciprocal is just the inverse tangent. So we take we take n as negative 1, we will have a I negative 2 and we still have something that we know how to integrate. Okay, so using this thing, I will just rewrite the whole thing. 2n plus 1 I n 2n plus 2n I n minus 1. So if you substitute n minus 1 here, we have a negative 1 I negative 1 2 power negative 1 minus 2 I negative 2. Okay, so you can see here we have the I negative 2 here, which we want to find the value of, and we have this I negative 1 here, which we know how to integrate. So if you have I negative 3, you don't know how to integrate that, so it will have a problem come out for us lah. So I negative 1, we know how to integrate. So let's try and rearrange this so that I negative 2 is on the left hand side. So here 2 negative 1 plus I negative 1 divided by 2. And yeah, let's try and evaluate this on the right hand side. So 2 in the reciprocal of 2, so it's 0.5. Then this I negative 1, I will copy this integral, but the n I will just replace with negative 1. Integrate from 0 to 1, 1 plus x squared power of negative 1 dx. Everything divided by 2. So 0.5 becomes 0.25. And I'll add half in front of this integral. And I'll also at the same time convert this into a reciprocal, right? It's easier for us to do the integration that way. So this negative 1 becomes the reciprocal of 1 plus x squared dx 0, 1. So this integral, you refer to your formula sheet again. You integrate this x squared plus 1 squared, which is what we have, 1 squared plus x squared becomes 1 over 1 tangent inverse of x over 1, which is same to say as the inverse tangent of x. So 0.25 plus this constant is still here, 0.5 of tangent inverse x. And we do the limit 0 to 1. And the inverse tangent of 1 is 90 degrees, right? So, sorry, 45 degrees. So, pi over 4 radian, and tangent inverse 0 is 0. So, we just have 0.25 plus 0.5 pi over, pi over 4, right? Minus 0. And finally, we have 0.25 plus pi over 8 if you simplify further. Okay, so this is the final answer, I believe. Yeah. So yeah, that's question 3. We'll proceed with the next questions shortly. So thanks for watching and stay tuned.